I welcome you all in online value-based course on chemical handling and laboratory safety organized by Department of Chemistry, Sri Shivaji Science College, Amravati, and my topic is handling and calibration of polarimeter. I am Dr. Ankush Wakote, Assistant Professor and Head, Department of Chemistry, Art and Science College, Kulgaon, District Kolkata. So, contents of my topics are introduction, plane polarized light, optical activity, instrumentation and working of digital polarimeter, and last, applications. So, what is polarimetry? In analytical chemistry, is a method for measuring the rotatory power of substance by the use of instrument polarimeter. Polarimetry is a superior, sensitive, and non-destructive measuring technique for the measurement of optical activity. The principle of polarimetry or optical rotation depend upon various factors such as the number of molecules in the path of electromagnetic radiation, concentration, length of containing vessel, wavelength, and temperature. So, what is plane polarized light? We also call it as PPL. The phenomena due to which vibration of light wave are restricted in a particular plane is called polarization. In an ordinary beam of light from the source, the vibration occurs normal to the direction of propagation in all the possible planes. Such beam of light called unpolarized light. If by some methods like reflection, refraction, or scattering, a beam of light is produced in which vibrations are confined to only one plane, then it is called as plane polarized light. In a plane polarized light, the plane containing the direction of vibration and propagation of light is called plane of vibration. The plane which is perpendicular to the plane of vibration is called plane of polarization. So here is a diagram, and from it we can see that there is an unpolarized light which is passing through this polarizer get polarized, means the light which is a normal light, or you can say it's the light which is propagated in all the direction called as unpolarized light, and when it is passed through the polarizers it only propagated only in one single plane, and that is called as polarized light. Then optical activity. So optical activity, the ability of substance to rotate the plane of polarized light when it pass through it. So there are two types of compounds generally, which is depend upon its optical activity. Means when the plane polarized light pass through the sample of its compound, and when it rotate the plane polarized light on right hand side, or we can say that clockwise direction, then it is called a dextrorotatory compounds, and it is denoted by small d or plus sign. If the compound which can rotate the plane polarized light in the anti-clockwise direction, means left hand side, are called as levorotatory compounds. It is denoted by small l or minus sign. And here is a D-bromochlorofluoromethane is the example which rotate the PPL light towards right hand side, or we can say that clockwise direction. And here is a L-bromochlorofluoromethane which rotate this PPL light towards the left hand side. So for the optical activity, the plane polarized light rotate. The magnitude of rotation depend upon the some factors. So which are these? So first of all, the nature of substance, length of liquid column through which light pass. Another factor, concentration of solution. Then nature of solvent, temperature of the solution, wavelength of the light used for this. So next, the types of molecule analyzed by polarimeter. So as we know, the molecule should be optically active. We can analyze the some inorganic samples as well as organic samples which having optical activity. So optical active molecule contain asymmetric carbon. So this is a example of asymmetric carbon containing compounds and which show the optical activity. Again, some examples where this asymmetric carbon is present, like lactic acid, glucose, fructose, sucrose, etc., which show the optical activity, and such kind of molecules can be analyzed by this polarimeter. So next, very important terms, that specific rotation. The specific rotation of a molecule is the rotation in degree observed upon passing polarized light through a path length of 1 decimeter at concentration of 1 gram per ml. So here is a formula, and from which we can say that there is a some there is small t which is given, and this small t indicate the usually it is a temperature that is 20 degree. There is a alpha which is given, it is observed rotation in degree. There is small l which indicate the length of sample tube in decimeter. Small c represent the concentration of the sample that which is in gram per ml, and d, capital D, represent the sodium D line, which is the wavelength of sodium at 589 nanometer, which is taken for this polarimetry. Now there are some compounds which show the specific rotation, and there are some values for this D glucose. It is a plus 52.7. For D sucrose, it is a plus 66.37. For D lactose, it is a plus 52.3, and for camphor, it is plus 44.26. Now, digital polarimeter. The demonstration of this polarimetric instrument, I will uh, provide the separate video for this demonstration. And now we are just going to uh, learn about this some panel introduction. So, what kind of panels present in that digital polarimeters? And I have taken this digital polarimeter of which is made up of electronics. It is a digital polarimeter of model number that is 801, and it having the first panel that is a sample tube. So number one, that is sample tube. This is the chamber for the placement of sample to be studied. The chamber can accommodate maximum length of 20 centimeter of tube. Along with that, this instrument, along with 20 centimeter sample tube, there is also 10 centimeter sample tube also present, and we can use any type of sample tube for your experiment as per your requirement. So next is the polarized wheel. Here is a number two which is given, and this is number two panel, that is a polarized wheel, and this is a wheel to rotate analyzer Polaroid of this system, and the position of this wheel is related to the degree meter. Uh, with this, using this Polaroid wheel back and forth, we can adjust the degree meter. So next is panel is that is intensity meter, and this intensity meter that is number three, which is read the intensity of light after it emerges from analyzer, and accuracy of the result depend on the how sharp minimum is located on this meter. The next panel is degree meter, that is also called a degree digital degree meter, and it is capable of reading about plus minus 20 degree to plus minus 200 degrees, sorry, plus minus 200 degree with the accuracy of 0.1 degree. So there is a number five panel, that is there is a shaft, and this is a 10 term pot used to calibrate the degree scale with the solution whose rotation is known. Means if you have the known solution, then you can use this calibration for the adjust this or calibrate this instrument. And this shaft is to be rotated with the screwdriver provided. Number six, that is a there is a switch which is called as on-off switch. And number seven, again there is a one adjustment for the zero, that is there is a shaft. This is a 10-ton pot used to set the degree meter to zero with blank solution. Blank solution means we generally taken it as a our distilled water, which is used as a blank solution for this experiment. And the shaft to be rotate with the screwdriver for adjusting the zero for the uh, water like sample. Okay. Now next is applications of polarimetry. It having a lots of applications. A very important technique it is used in the medicinal science also. And I'm just going to do some applications here. The polarimetric principle is the polarimeter can be used in this polarimetry. Polarimeter can be used to identify the isomer present in the cell. We can identify the isomers, whether it is a L form or D form. Many chemicals exhibit specific types or specific value of optical rotation. Therefore, the polarimetry principle can be used to identify unknown samples based on the specific rotation. Specific rotation data is also used to calculate the concentration and the purity of the chemicals. We use the polarimetry from the analysis of antibiotics and enzymes. So last, thank you for giving me a chance to talk about this handling and calibration of polarimeter in this workshop. Thank you. Thank you very much.